Hello, everyone. I am going to attempt to solve a more complicated question. It's called a investigative problem. You get one of these per exam. They combine multiple units, and they are uh, really fun. They're like the most original question on the test. As long as you feel fine with your understanding, it should not be a problem. And then they tend to be a little bit more handheld because a lot of these things are um, have to be stringed together. So the writer of the exam tends to make them really easy from step to another step. So let's take a look at the problem. Okay. Okay, I don't want to block this. I want you to work out one problem at a time and then well, pause the video and try to work out one problem at a time. And once you have it, you will play the video so you can follow along. Okay, let's see. 100,000 tortillas from each. So they produce 100,000 here, 100,000 here. 2 production lines. Sounds good. And 200 tortillas are going to be sampled. The true average of that is 6 inches. Okay, cool. Take a random sample of 200 tortillas from the 200,000 tortillas. Okay, so this one is after they have combined. So remember there's 100K here and there's 100K here. So they have combined it and then you randomly select 200 of them. That one sounds pretty good. This one, randomly select one of the 2 production lines. So either select production line A or selection production line B. And then you take 200,000 either from here or from here. Well, okay, from that is the answer. All right. This one sounds bad because if you do this one, you will it will be a biased estimate of the true average, right? Okay, so let's see. From method 2, representative of the population that made that day. No. Maybe I can type it. No, it will not be representative of the tortilla is made tortilla made that day. You will consistently underestimate the true mean if you pick line A, and you will consistently overestimate if you pick line B that particular day. Maybe we add some values to make sure they look nicer. So this one, mean of 5.9. Here, mean of 6.1. Looks like I blocked some values. Okay, cool. Next question. Move this one. Okay, pause the video and do this problem. Okay, so you have paused it. The figure below is a, oh, by the way, I want to stress, it's really important that you pause the video. These questions are really hard to come by. There's only like 30 of them. And then so don't waste them. Really try every single one of them. Try to understand the nuance of what they're asking so you can get a good feel of what it will actually feel like on the day of the exam. Okay, all right. So the 20 timers. So this one, as you can see, that this is bimodal. If you had chosen it sample one, it will look like this because this is the original population, right? So if you randomly pick 200 of these, right now there's 200,000 here. If you randomly pick 200, it will look something like this. It will look bimodal. If you use method two, you will look rather a normal distribution, but it will underestimate if you pick this one, overestimate if you pick that one. So with that in mind, let's write the answer. This graph is most likely obtained from method one. Method one is the sample of randomly picking 200. So explain. Since the population is a bimodal graph, the sampling distribution, no, this is not the sampling, the sample of randomly chosen to the 200, okay, the 200 randomly chosen, I guess a tortilla, will resemble that shape because at 5.9 and 6.1 are the most likely, I guess, frequency. Yeah, I guess that's good enough for me. Okay. Now, number C. Please pause the video and do C. Move this up a little so we'll give some. Pause the video. Which of the two sample methods, method one or method two, will resemble less variability in the 200 sample? Oh, this one is easy, right? This one is, of course, method two. Method two. Because method two, you will choose either A or you will choose B, right? This one is 5.9 and then this one is 6.1. If you choose method one, you will look something like that. Well, which one has a higher variability? Well, of course, method two. This is method one. So explain, okay? So you can explain it just by graphing, adding some graphic illustration. So just like what I did, and okay, I'll write underneath. Method two will result in less variability because the 200 tortilla will center either around 5.9 or 6.1. But I guess with a lower spread than method one. You can just write lower spread equals less variability. All right, D. So pause the video if you're doing D. For sample size of 200 taken from that data program, put attention. Oh, so right now this is the sampling distribution of the sample mean. So you've done that before. So we are going to describe the sampling distribution of the sample mean using method 1. So this is the parent population. We've been doing this so many times, as you can see. That's why I picked this problem because it's unit 5. So this is the parent population. Let's see. The average is 6. Does it mention the standard deviation? No. Tortilla produced around 6 inches. Okay. Wait, am I missing something? Maybe it's not given to you. Okay, let me read it again. Okay, and this question, for sample size 200 taken from 1 day's production, describe the sample mean diameter for the samples that are obtained using. Yeah, all right. So I guess we don't have it. I guess we just have to describe it. Yeah, all right. We take a sample size of 200, and then this average is 6. So you can say that so you will write the sampling distribution of the sample mean will look normal because SRS, because of sample size, you're taking 200, so n is greater than 200. And then that day they produce 200,000, and then you only picking 200 of them. So there are more than 2,000 tortillas times 10. All right, so the average is going to be 6. And then, unless I missed it, that's weird. So the standard deviation, this is going to be the average of that. And then this is going to be the standard deviation of, I'll just write the standard deviation of the population divided by the square root of 200. I still can't believe they didn't give it to you. Okay, I mean, okay, whatever. Suppose that 2 of the sampling methods will be, so this is E, pause the video, do it please. Suppose one of them. So now that you have done number E, suppose that one of the sampling methods will be selected, used every single day. The mean of 200 will be recorded each day. Which 2 methods will be less variability? Okay, so think about this. Using method 1, your average for 1 day, remember you're doing this 365 days. The first day, the average is going to be around 6 for sample 1. The second day, the average is going to be around maybe somewhere around 6-ish. And then the third day, it's going to be somewhere around 6-ish. Okay, or 6.1, slightly, or maybe 6.05. Maybe the fourth day, it's going to be slightly less. The average is going to be 5.98, whatever. But it's going to be very, very close to 6 because 6 is the true value, and you're picking sample size of 200. So this is kind of like the sampling distribution of this one, right? All right, using method 2, first day, you might pick something that will be 5.9. And then the second day, you might pick something that is 6.11. And then the other one, and then you're going to pick another day, is over here. It's going to be 5.91. Okay, so as you can see that these numbers are way closer to each other than these numbers. Remember, you have to do this 365 times. So you just have to explain it. You can just write sample method 1. We'll have less variability. Method 1 will have less variability. Right? Even though both of these are unbiased. So you can, this question is kind of unique in the sense that even though this one has less variability, it's the better method. And this one, wait. Well, they have, okay, these two, this one has less variability. In this one, you have less variability in this one. But if you combine them, they will cause more variability in the combined center. But if you do a select 365 days, each day, if you select 200, they will cause less variability. So this question is actually very interesting. So less variability because, of what I said, because method one will create numbers closer to 6 most days. And then method 2 will have higher variability because most of the numbers, so you can just draw these pictures if you want. Number 2 will create higher variability because the answer will be around 5.9. Will set, okay, so 2 common frequencies will be around 5.9 or 6.1. These, you can see that these numbers are further apart. So you have a bunch of 5.9s, a bunch of 6.1s, as opposed to this one, more 6s. So less variability. Okay, government, so you have to pick one day. Yeah, of course. For this one, the answer is obviously method 1 because of all these reasons that we just said. Every day, this one, most of the results will be around 6, but most of these results will either be around 5.9 or 6.1. So you should have the government check out method 1. All right, that's the video. If you solved all of this by yourself, good job. See you. Okay, I'm going to stop the video.